In this lecture, we're going to see how we can manage our class objects through pointers. And in most cases, we need to manage our class object through pointers if we are using some form of dynamic memory allocation. Here is a simple example. We have our cylinder class included, and down here you see that we can create cylinder objects on the stack. If we use the syntax like we do here, the objects are going to be created on the stack. And we have seen that we can access the behaviors or data inside our class object using the dot notation like we do here. For example, here we are calling our volume function. But sometimes we want to manage our objects through pointers. For example, if you look at the syntax we have here, we are saying cylinder and using the asterisk here. This is going to say that this is going to be a pointer to a cylinder type. And I'm going to give it a name C2, and we can allocate our object on the heap using the new operator. This is going to dynamically allocate space from the heap, and that memory space is going to be used to store our cylinder object. Now, the interesting thing is going to happen when you try to access behaviors from your cylinder object here. For example, if we look at this line here, we are trying to print the volume of this cylinder, and you notice that we have to go through ugly dereferencing here. We have to dereference the object and then call our method through the dot operator here. But what I want you to see is that we can avoid this ugly dereferencing we are doing here and use the pointer access notation. This dash greater than symbol you see here is going to allow us to access stuff directly using the pointer to an object that is dynamically allocated on the heap. Okay, after we are done using our cylinder object, remember it is memory that was dynamically allocated from the heap. We have to release the memory so that it can be used by the operating system. And we release the memory using the delete operator as we do here. Okay, the idea I wanted to introduce here is that we can use pointers to manage our cylinder objects. And this is one way we can do this. And once we are using a pointer as a handle to our cylinder object, we can use the pointer access operator here to access stuff from our class objects easily. And another thing you should know is that we can actually create a cylinder object and store in the address of objects that we have on the stack. And we're going to see this in a minute when we hit Visual Studio Code. Now that you have an idea about this, let's head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is managing class objects through pointers. We can see the entire name here. And now we're not going to grab our template project because we want to start from the project we had in this lecture on class across multiple files. So we're going to go in that project and grab everything from there except for the executable because we obviously don't want this. And we're going to go in our current project and paste in the code. And this is going to give us a good starting point. So we can grab this and open this project in Visual Studio Code. It's going to open the folder and we're going to have everything we want to start doing what we want to do in this lecture here. So now we should have access to our cylinder class. And if you look here, we have an object of cylinder type already created by this line on line number 6 here. And we have seen that we can use the syntax like cylinder volume here using the dot call operator to access stuff from our class object. And this is going to work, but we want to see that we can use pointers to manage our object here. And the first thing I want you to see is that we can manage a stack object through pointers. And to really show this off, let's set up another variable. It's going to be a cylinder pointer, and it's going to be pCylinder1. It's going to be a pointer to cylinder1 here. That's what I mean. And we can give it an address of cylinder1 as a value. So we can do that, for example, and put in the address of operator, and this is going to work. Now we can go through our pointer here and do stuff with this cylinder object. But the syntax is going to be pretty ugly. So for example, let's try and print the volume of a cylinder. we're going to say stdc out and say volume. We can save that. And we're going to have to go through the dereference operator. So if we do something like p cylinder 1 and try to use the dot operator, you're going to see that we have the volume function. But if we try to call it, let's do that. Let's make sure we are using the dot operator here. If we try to compile this program, it's not going to compile because we are trying to call stuff from a pointer. And remember, a pointer is just going to store an address. It doesn't really have information about the type that it is pointing to. If we try to compile this program, we're going to get a compiler error. So let's use GCC to do that. And we're going to get request for member volume in p cylinder 1. Remember, p cylinder 1 is just a pointer. It's not an object. So we can't really call the volume function to it. If we want to use the dot call operator here, we have to dereference and actually get to the actual object that the pointer is pointing to. And we do that using the star operator. You already know how to dereference a pointer. So we can dereference our pointer and then call the volume function on what the pointer is pointing to. And this is going to work. It's going to print our volume. Let's build now that we are dereferencing correctly. And you see that this is going to work. And if we try to print this, let's bring up a terminal so that we can run this program. Let's run Rooster. You're going to see that we have our volume here. So to really get to what is pointed to, you need to use the dereference operator and then call whatever method you want to call on your object. But we can do things even easier. There is a syntax we can use to use the pointer directly here, because going through all this dereferencing ugliness is really not cool. So we're going to grab this and show you that we can use the dash greater than operator. That's how I call it. And if we use that, we don't need to dereference. All we need to do is use the dash greater than symbol here. And it's going to directly tell the compiler, don't call stuff on the pointer directly. Do dereference the pointer internally and then call the volume function on whatever you get after dereferencing. So this is basically going to push the dereferencing ugliness here behind the curtains of the compiler, and we can use a nice syntax like this. And I think this is much better than what we were doing here. So if we try to build now, we're going to build and print our volume. You're going to see the build is good. We can clear and run Rooster. You see, we see our volume here. So this is what I want you to see. It is possible to manage your cylinder objects through pointers. And this is one way we can do this, by managing a stack object through pointers. And this is what we are doing here. If you want to call stuff on your class object, you can either do the ugly stuff we do here, or you can use the nice pointer access operator, and it is going to be cool. Okay, now that we have seen this, let's see another use case in which we're going to be creating a cylinder object on the heap through the new operator. Okay, we can go down and save that. We're going to say cylinder pointer. It's going to be p cylinder 2. We can call it like this. And then we're going to say new cylinder. And you're going to see that we can call a constructor. We have two types of constructors we can call. We're going to call our constructor that takes two parameters, and we can pass in 100 and 100. Why not? Oh, let's put a 2 after here. We can put in whatever we want. This is going to create a new cylinder object. The space for the cylinder object is going to be allocated on the heap. So this is a heap object. And because we are using the new operator here, the other thing you should have in mind is that you will need to release this memory. And let's go and do that directly. This is a good practice because you will forget to release your memory if you don't really keep this in mind. So we are going to delete p cylinder 2 because that's what we used to allocate our heap memory here. Okay, now that we have taken care of memory management, we can go in and use our p cylinder 2 object. And for example, we can print its volume by using the stdcout statement here. So let's go down and save that. Let's align this properly. And we're going to say volume cylinder 2 to really make this super clear. And then we're going to say p cylinder 2 and call the volume function here. This is going to work. Let's try and build. The build is good. We can clear and run Rooster. This is going to give us our volume, and if we try and use this information to create a cylinder, we're going to see that the volume is what we see here. We can even try and print its base radius. Let's do that. We're going to say stdcout. We're going to say p cylinder 2, and we're going to say base radius. We can hit the dot operator here. You're going to see we're going to have a few options in Visual Studio Code here. If we double click on get base radius here, you're going to see that Visual Studio Code is going to use the pointer access operator here. And this is really cool. So we can hit stdendl. We can close the left pane here because we need some more breathing space. And if we try to build and run this program, and we have a compiler error here, and the reason is getBaseRadius is a function. If we go back in our cylinder class, we see that we have a function called getBaseRadius. So if we want to call this in the main function, we need to call that as a function. So we need to put a pair of parentheses here. And if we build, we should build without a problem. Let's do that again. You see the build is good, and if we run the program, we're going to see exactly what we expect. Let's run a Rooster. We're going to see what we expect here. And the message here was really that you can manage your class object through pointers. One case is when you have a pointer that is pointing to a stack object, and we saw that we could do that here. We can also use pointer notation to allocate objects on the heap and point to them with our pointer here. And whenever we are using a pointer, we have the option to use the pointer call operator here to do things easily. I am going to be calling this the pointer call operator to mean this from here on if we happen to need this, and you should know what I mean by that. This is really all I set out to share in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to learn about the structures. Go ahead and finish up here and meet me there.